In this video, we're going to be converting from mass to particles. So looking at this question, let's look at what's given and what we're going to be solving for. So what's given is we have 220 grams of CH4, and what we're solving for is that we're solving for particles. So let me get my highlighter and we'll start highlighting this. We're solving for particles of CH4 specifically. So solving for particles of CH4, and we're given grams of CH4. Specifically, we have 220 grams of CH4. So whenever we're solving a problem like this, we're going to start with what's given and then keep in mind what we're solving for. So I have 220 grams of CH4. I'm going to write that down. All right, 220 grams of CH4, and eventually I need to get to particles. But just like in our last video, we pointed out that we can't convert from grams to particles. We have to use this intermediate step of converting to moles first. So how can we convert from grams to moles? Well, we're going to look at our periodic table and figure out the molar mass of CH4 and use that to convert from grams to moles as our first step. So let's look up the molar mass values of C and H. So let's find CH4 molar mass. So first, let's find the molar mass of, let's do C first. So carbon's molar mass, we look up on the periodic table, is 12.011. So 12.011 grams per mole. And then we can find hydrogen's molar mass on the periodic table as well. Let's look that one up. All right, for hydrogen, the molar mass is 1.008. 1.008 grams per mole. And then I'm going to combine those together and find the molar mass of CH4. So specifically, we have 1 carbon and we have 4 hydrogens. So we're going to get a molar mass of 12.011 plus 1.008 times 4. So 12.011 plus 1.008 times 4. And we get 16.043. So CH4's molar mass is 16.043 grams per mole. So we'll write that down, both ratios of that. We'll write down we have 16.043 grams of CH4 for every 1 mole of CH4. Or we could say that we have 1 mole of CH4 for every 16.043 grams of CH4. All right, both of those, one of those is going to be more useful than the other, so let's see what we need. Given that we have grams in the numerator here with what we're starting with, or where we're at in the problem, and we don't want grams in the final answer, we want particles in the final answer. So since that is the case, we are going to want to cancel out the unit of grams. So we're going to go with one of these that has grams in the bottom, which is this one. So by having grams on the bottom, we can cancel that unit. So let's use that one on the bottom. Let's use this equation on the right. So there's 1 mole of CH4 for every 16.043 grams of CH4. And then that will help us cancel the unit of grams. So grams can cancel. All right, but we're not done solving yet. We now have solved, if we were to plug this into our calculator and get press equals, we will get an answer in moles. But since moles is not the final unit that we want to get, we need to do another conversion in order to get our final answer. So you can break this off and have this and get your answer in moles, and then solve again. You can start with the number of moles you have and multiply it by something else to get particles. You could do it in 2 different steps, but I like to do it all in one step, so let's do it that way together. So right now we have moles, and we need to cancel out the unit of moles and get to particles. So what's going to be useful here is our ratio of the number of particles per mole. So everybody should know this by this point, how many particles per mole, because that number doesn't change. It's the same for every single element, every single compound in existence. So, because a mole is just 6.02 times 10 to the 23rd of anything. So let's move everything down a little bit so we have a little more room. And we'll write down our other useful ratio. So we know that there are 6.02 times 10 to the 23rd particles of CH4 for every 1 mole of CH4. Or we could say that there is one mole of CH4 for every 6.02 times 10 to the 23rd particles of CH4. All right, we're going to look at these 2 ratios and see which one's going to be more useful in this question. And the answer is it's the one with moles on the bottom, so that we can cancel out this unit of moles that we have in the numerator over here. So we're going to use this one right here. So we'll write that down. So we're going to multiply this times 6.02 times 10 to the 23rd particles of CH4 for every 1 mole of CH4. All right, by doing that, we will be able to cancel the unit of moles. More specifically, I guess we canceled out grams of CH4, and now we canceled out moles of CH4, and we're left with particles of CH4. All right, and I'm going to make this a little bit smaller, and then we can plug this into our calculator and get our final answer, because we are now in particles of CH4, which is the unit that we're solving for. Let's go back to what we set up here. We were trying to solve for particles of CH4. So we have highlighted in pink. We're trying to solve for particles of CH4. So now that we have that, we just plug it into our calculator and get our final answer here. All right, let's plug that into our calculator, see what we got. All right, so we'll write down 220 times 1 divided by 16.043 times 6.02 second E 23 divided by 1. All right, and we get a final answer of 8.25 times 10 to the 24th, or 8.26 times 10 to the 24th. So we'll get our final answer. I'll write it in pink because that's what we're solving for. 8.26 times 10 to the 24th. 8.26 times 10 to the 24th. Particles of CH4. All right, 8.26 times 10 to the 24th particles of CH4. So now we have our answer in particles, so we are done. We got the final answer here.